Okay, so we have this is a polynomial question. It has a remainder of 2 when divided by x minus 2. That means our polynomial, right, has when it's the divisor. So polynomial is divisor polynomial times by the quotient polynomial plus the remainder polynomial. This is where we should start. The divisor is x minus 2. When it's that, they tell us that the remainder is 2. Okay, it's a quartic function, so that means this right here, quartic is degree 4. It has to be degree 3, so they multiply with this to get degree 4. So this has to equal to degree 3, meaning qx will be ax cubed plus bx squared plus cx plus d. This is a general form for cubic polynomial. And has a y-intercept at 6. Means if you plug in 0 for x, so you get 0 minus 2, q at 0, okay, plus 2. This is going to equal to 6. So you get negative 2. Let's plug in 0 in here. You see that the only thing that's going to be left over when you plug in 0 is going to be d. So d plus 2 is equal to 6. So minus 2d is going to equal to 4, and d is going to equal to negative 2. Okay, so we found d. Okay, and the next two information by factor theorem, right? This from right here, x plus 1 is actually a factor of our polynomial x. Okay, or f at x, I should say. Also, 3x minus 2 is also a factor, okay? Also a factor as well, because when you plug it in, you get 0. So in other words, our p at x, right, is x plus 1 times by 3x minus 2 times by 2 other factors. I think the best way to approach this problem here, if I could just find a, b, c, we already found d, right? We can get the entire polynomial. Now, if I plug in negative 1 right, in here, I get a remainder of 0. That's the same thing as saying, negative 1 in here, I will get negative 2. Right? So let's plug in negative 1 in there. So you get negative 1, negative 2. Q and negative 1 will give you a minus a plus b minus c. Of course, d is minus 2. This is equal to 0. Okay, so we can actually this is equal to minus 2, right? So it'll add with this 2 to become 0. Okay, so we have minus a plus b minus c minus 2 is equal to negative 2 over negative 3, which is 2 over 3. And let's add both sides by 2. Negative a plus b minus c is equal to 8 over 3. So a minus b plus c is equal to 8 over minus 8 over 3. So I just multiply both sides by negative 1. So I'm going to say, label that as an equation 1. Okay. So we have some kind of relationship between a, b, c. Now, we can also plug in 3 over 2. Okay. So plug in 3 over 2 in here. 3 over 2 minus 2. And plug in 3 over 2 in here, and we get a 27 over 8a, 9 over 4b, plus 3 over 2c minus 2, right? D is already minus 2. This is going to have to equal to also negative 2, right? Negative 2, so that it adds with 2 to give you 0. This is equal to negative 2. This is not as pretty. Okay, so this is 3 minus 4, that's negative 1 over 2. Okay, so you get 27 over 8a, 9 over 4, b plus 3 over 2c minus 2 is equal to positive 4. Okay, you can bring this negative 2 to the other side to get 6, right? Apply, actually, let's divide everything by 3. 27, 9, 3, 6, all multiples of 3. Divide everything by 3 and you get 9 over 8, a, 3 over 4, b, half c is equal to 2. Okay, and then let's multiply everything by 8 to get 9a plus 6b plus 4c is equal to 16. This is going to be our second equation. And lastly, I'll do it up here. When you divide by x minus 1, that's the same thing as plugging in 1 in here. So you get 1 minus 2. Okay, this is going to be a little bit nicer. Negative. Plugging in 1 in here is very easy. It's just a plus b plus c minus 2 plus 2 is equal to 0. Or this is equal to negative 2. So you see that this right there, a plus b plus c would have to equal to 2 for this to be true. This is our equation 3. Let me bring it down here. In fact, it looks very nice. I think it will look very nice beside equation 1. A plus b plus c is equal to 2. It's equation 3. Okay, note that the coefficients of a and c line up. So we can actually subtract equation 1 and equation 3. Just subtract it and you get a minus a is 0. Minus 2b, c minus c is 0, is equal to minus 8 over 3 minus 2. That's negative 14 over 3, so b is equal to 7 over 3. Okay, 7 over 3. Okay, so now we can actually plug that into all three of the equations. Okay, so let's get equation 1. I'm going to call this condition 4. 4 plug into 1. You get a minus 7 over 3 plus c is equal to minus 8 over 3. So that's going to be a plus c is equal to, right, minus 1 over 3. Okay, so using this, I can actually isolate for c, for example, minus 1 over 3 minus a, and replace b with this, right, and c with this, and we get an equation with all a's. So we have 9a, okay, 9a plus 6 times by 7 over 3 plus 4 times by negative 1/3 minus a is equal to 16. Okay, so you get 9a, reduce this, and you get 14, right? And you get negative 4 over 3. Negative 4a is equal to 16. Collect these two, you get 5a. Collect these two, and you get 2 on the right side. Collect these two, you get 2 plus 4 over 3. So that's going to be 6 plus 4, that's 10 over 3. Divide both sides by 5, you get, right, you get 1 over 3. B, finally, c is going to be negative 1 over 3 minus 1 over 3, negative 2 over 3. So after all of that, so remember, our equation was this, right? So it was polynomial x at x minus 2. It was ax cubed plus bx squared plus cx plus d, our cubic general polynomial, and the remainder was positive 2. Okay, so our answer is x minus 2. A is 1 over 3. B was, where's B? 7 over 3. C is negative 2 over 3. And D, where was D? D was up here, right? No, where's D? We found D first, right? Oh yeah, negative 2. plus 2. Okay, and if you want to simplify, you can factor out 1 over 3 and expand and so on, but I'm going to stop right there.